Okay, so here are our notes for double and half angle identities. I told you guys on Tuesday that sum and difference and double and half angle identities are not the ones I'm most concerned with, but I am afraid that you're going to see them on the final exam. You might not, but I'm afraid that you may. So I want to skip them, but I'm not going to because of that. So double angle identities. So our first double angle identity, sine of 2 times theta is 2 sine theta cosine theta. Okay? I don't have any cute songs to help you remember these. I haven't ever heard any. If you guys want to make a song, there's some extra credit. Cosine of 2 theta is cosine squared theta minus sine squared theta. This is the one that you have to have memorized for that quiz. However, sometimes it's more useful to use one of these two cosines here. So these will be a bonus on that trig identities quiz if you want to memorize those. I don't make you memorize it because, like, if I wanted to change, if I wanted to change this to all cosines, I could change this to cosine squared theta minus 1 minus cosine squared theta, like that, which would give me cosine squared theta minus 1 plus cosine squared theta. And then if I put those two cosine squared thetas together, I would get 2 cosine squared theta minus 1. These two right here, these bottom two are extra credit. So you don't have to have those memorized because you could still solve those even if you did not have those memorized. So these are bonus. There is also a separate identity for tangent, but I have found that it's really just going to be easier for us if we just say tangent of 2 theta is sine 2 theta over cosine 2 theta. So we just need to find the sine and cosine first for that. Because I can't scroll up. Alright, so tangent should be a simple one to memorize. You're just sine over cosine. You pretty much already know that. You just have 2 theta instead of a single theta. So let's look at the problems that you're going to have for these. So we are given that sine theta equals 2/3. We're going to try to find sine of 2 theta and cosine of 2 theta and tangent of 2 theta. So let's start with sine of 2 theta. We cannot just multiply this by 2. It's not the same. This 2 is only inside of our parentheses if we had written them there. So we can't just sort of pull that out and multiply everything by 2. So what we have to do is we have to use the formula. Sine 2 theta is 2 sine theta cosine theta. And I know that sine of theta is 2/3. So I can plug that in right here. So I've got 2 times 2/3. But I don't know cosine of theta. How could I find cosine of theta? I could do sine squared theta plus cosine squared theta equals 1. So that would be 2/3 squared plus cosine squared theta equals 1. This is more like what you're going to see on the test because it's not going to be calculator active. So this I would expect you to be able to do by hand without a calculator. So we'll have 4 over 9 plus cosine squared theta equals 1. I would subtract 4/9 from both sides. And when I do that, 1 minus 4/9 is like 9 over 9 minus 4/9. So that is going to give me 5 over 9. And I will square root both sides. So I will get cosine of theta equals square root of 5 over 3. Okay, so cosine of theta is square root of 5 over 3. And now I just have to multiply that stuff together. So this is 2 over 1. So 2 times 2 times square root of 5. I multiply the things on the outside of the square root together, so that would be the 4. And then nothing else can go with that square root of 5, so it stays there. And then 3 times 3 is 9. So this would be my answer. Okay, questions? Okay, it's kind of like that question that we did whenever we were going over homework. It's just you're plugging those things into different formulas than we were using on the homework. For B, cosine of 2 theta, the formula for that is cosine squared theta minus sine squared theta. So I already know that sine is 2/3. I just found that cosine is square root of 5 over 3. So I would have square root of 5 over 3 squared minus 2/3 squared. And so when I square this, I will get 5 over 9 minus 4 over 9. What does that give me for my answer? 1/9. So basically, you need to find your sine of theta and that cosine of theta first, and then you're just going to plug that in to whichever formula you need to use there. And then tangent of 2 theta, since we've already found sine and we've already found cosine, we're just going to do sine over cosine. So we're doing sine of 2 theta over cosine of 2 theta. Sine of 2 theta was 4 square root of 5 over 9. And cosine of 2 theta was 1 over 9. What should I do here? I don't want to leave it like that. Flip the second and multiply. So 4 square root of 5 over 9 times 9 over 1. I could multiply, but what would help me first? Cancel those 9s right there. So I just get 4 times the square root of 5 over 1. Mm-hmm. All right, questions? Mm-hmm. All right, here's our next one. Now, just like the last one, this time I've got cosine theta. What am I going to need to be able to do any of these problems? Sine of theta, right? Because all our formulas have sine and cosine. So I'm going to say that sine squared theta plus cosine squared theta equals 1. So sine squared theta plus 4/5 squared equals 1. This is another one like you might see on your test. I'll expect you to be able to do this without a calculator. So sine squared theta plus okay. Nine over 25. What's the last thing we do here? Square root. So we get sine of theta is 3 over 5. Okay, so once you have these two pieces of information, you're just plugging things into the formula, whichever formula you need to use. So this formula is 2 sine theta cosine theta. So that's going to be 2 times 3/5 times 4/5. And that 2 is like a 2 over 1. So we've got 2 times 3 times 4, which is going to give us 24. 4 over 1 times 5 times 5 is going to give us 25. So we get 24 over 25 for sine. Questions there? Cosine 2 theta, that's going to be cosine squared theta minus sine squared theta. So we're going to have cosine is 4/5, so 4/5 squared minus sine is 3/5, so 3/5 squared. So that's going to give us 16 over 25 minus 9 over 25, which will give us 7 over 25. And questions? Alright, tangent of 2 theta, we just need to do sine 24 over 25 divided by cosine 7 over 25. And dividing fractions is easy as pie. Flip the second and multiply. You'll notice this usually happens right here. Those cancel, those 25s cancel. So we just get 24 over 7 for tangent of 2 theta. We're going to skip a couple of them. We're going to do example 3, though. We're going to skip example 4. Okay, so example 3, we need sine and cosine. They didn't give us sine and cosine. They gave us cotangent, which is aggravating. But we have Pythagorean identities that have cotangent, right? What is that identity? Equals cosecant squared. Okay, so that other identity we're going to have to use here because they didn't give us sine or cosine to begin with. And when we find cosecant, what can we do to turn it into sine or cosine? flip it, right? 1 over sine. So we're going to have 1 plus 12/5 squared equals cosecant squared theta. So this is going to give us 1 plus 144 over 25. And then that's going to be 25 over 25 plus 144 over 25. And 144 plus 25 gives us 169. Cosecant squared. What's the square root of 169? 13. So 13 over 5 is cosecant. So what would sine of theta be? 5 over 13. We can just flip it to get sine. Now what's aggravating about this problem is you still don't have cosine, and you need cosine to be able to find these. So once you've found this, you still have to find cosine. How do we find cosine? Sine squared theta plus cosine squared theta equals 1. So like we did on the first problem. So these are a little bit longer if they don't give you sine or cosine to begin with. So we'd have 5 over 13 squared plus cosine squared theta equals 1. So that'd be 25 over 169 plus cosine squared theta equals 1. We would subtract 25, so we'd get cosine squared theta equals, or subtracting 25 over 169. 144 plus 25 gave us 169, so 169 minus 25 is 144. And then we'll square root both sides, so cosine theta is 12 over 13. So these two pieces right here are what we're going to need to plug into our formulas. They're a little harder to get on a problem like this. Okay, questions there? Alright, so now we just plug into our formulas. Questions? Yeah, 144. And this is sort of the upper limits of what I'd give you without a calculator. So you won't see you might see this, but you probably won't see any numbers bigger than this on the problem that you're asked to do without the calculator. The homework may have bigger numbers on it because the textbook allows you to use a calculator on things. So the homework may have bigger numbers. It's fine to use the calculator on the homework whenever you have bigger numbers, but just know on the test you're going to have to be able to do this without a calculator. So, but they will be smaller numbers. So here we'll have 2 sine theta cosine theta, so that'd be 2 times sine is 5 over 13, and cosine is 12 over 13. So it's like 2 over 1, or we're going to get 10 times 12, which will give me 120, over 13 times 13 is 169. There's my sine of 2 theta. Then I'll have cosine squared theta minus sine squared theta. That is going to be, cosine was 12 over 13, and sine is 5 over 13. So I get 144 over 169 minus 25 over 169, and that is going to give me 119 over 169. Questions so far? And then last we would have 120 over 169 divided by 119 over 169. Dividing fractions is easy as pie. Flip the second and multiply. Again, 169 is canceled here. We get 120 over 119. Okay, questions? Alright. Okay, we are going to skip example 4. I'm not going to give you one like this that says cosine of 4 theta, because it makes it where you have to do the problem twice. We're not going to do that. Okay, here's your next one, example 5. This we will need to do. Alright, so this is an identity that we have to verify, which means we only want to work on one side of the equation. So this more complicated side over here is probably where we want to go. Put my line like that. So whenever you see that you've got that cosine of 2 theta, you cannot cancel or simplify or do anything when you've got cosine of 2 theta. So you want to use your identity that you know to help you solve this, right? Now, it would be easier on this one if we look back at our oh gracious, identities, if I can ever get there. There they are. If we were to use this identity right here, it would be quicker because it only has cosine, and then it's going to probably factor or cancel with something in the denominator. However, most of my students are doing good just to have this one memorized and not the extra ones, right? I myself am doing pretty good just to have that one memorized, and I've taught this for several years. So all of these I'm going to work out like we're going to use. It's a little bit longer, but I'm going to use cosine squared x minus sine squared x. So this cosine of 2x I'm replacing with cosine squared x minus sine squared x. It could be made shorter if you use those other ones, but I think there's a good chance there's a lot of you that won't have those memorized. So we're going to go this route. Makes it a little bit longer, but you can still get the same answer. Now what we should notice is that we've got a sine squared in the top. There's no signs in the bottom. Also, the other side of the equation does not have a denominator. So we know we want something to cancel with that denominator so that we don't have a denominator on this right side either. So in order for any of that to happen, I'm probably going to need to get rid of sine squared x. So what I'm going to do is I'm going to replace it with 1 minus cosine squared x. Make sure when you replace it that you put parentheses around it because you have to distribute that negative right there. Okay, if you forget to do that, your cosine squareds will cancel and you won't be able to get to the right answer. So you're going to get cosine squared x minus 1 plus cosine squared x minus 1 all over 2 times cosine x plus 1. Now, I want you to see something. I can put these cosine squared x together, and I will get 2 cosine squared x minus 1 minus 1, which is minus 2. If I had used that shortcut identity, the one that's a bonus, then I would have ended up right here a lot quicker. But that's only good if you actually have the identity memorized. I'll give you a second to look at this. What questions do you have? Yes, on this step right here. And then right here at the sine squared x, we can replace it with 1 minus cosine squared x, because that's an identity that we know also. Alright, any ideas of what we can do now? What would we factor, Chloe? Okay, we can factor what? You can't pull a cosine out. You can factor out of 2. So I'm going to go back up here because I'm running out of room. So I have 2 times cosine squared x minus 1 over 2 times cosine x plus 1. And then the 2's will cancel there. Now, you might be tempted to do some bad canceling here. So you might be tempted to mark out like a cosine x with one of these cosine x's and then like cancel those 1's to get cosine x minus 1, but that is not correct. Because we cannot cancel when we got those plus and minus signs in between. I can factor the numerator. What can I factor the numerator to be? Almost, but switch them around. The cosine has to come first. Yeah. So cosine x plus 1, cosine x minus 1 over cosine x plus 1. Now what can happen? These 2 can cancel because now you don't have an addition sign between. That's multiplication there. So they cancel and we're left with cosine x minus 1. Alright, I'm going to give you a second to look through that one and see what questions you have. Now, that one was a pretty tough one. The sum and difference ones are usually fairly easy, in my opinion. This is difficult, but the thing to remember is that the only thing that was different about this was that very first step, and then everything else was stuff I could have given you before, right? I could have given you this. I could have given you this start. This is your start equation. And then we could have done that whole thing before we knew about the double and half angles. So really the double angle is only adding just that one first step. The rest of the stuff is stuff we've done before. Alright, questions? Alright, here are our half angle identities. And I will admit, I don't love these, and I don't have them memorized all that well. But we do need to memorize them for the quiz. You are going to need to have them memorized for the test that we will use. So we've got sine of theta over 2 is plus or minus 1 minus cosine theta over 2. Cosine of theta over 2 is plus or minus 1 plus cosine theta over 2. And then tangent is theta over 2 plus equals tangent of theta over 2 equals plus or minus the square root of 1 minus cosine theta plus and 1 plus cosine theta. Here cosine theta cannot equal 1 because if it did equal 1 you would get a 0. You get 0 over 1. Let me double check. here's the problem right here. That should say cosine of theta cannot equal negative 1. Because negative 1 will give you 0 in the denominator. So fix that on your notes there. That should say negative 1 instead of positive 1. On the identities on the quiz, if you leave that cosine cannot equal negative 1 off, I'm going to be okay with it. As long as you got this part right, you'll get credit for the problem. Okay. Now, half angle identities. The problem's going to look something like this. This should look familiar to Chloe. This is what Chloe did on the warm-up, right? Because she saw 7 instead of 17. But it can be done, this problem can be done with sum and difference identities. But it also can be done with half angle identities. So half angle identities, we're not going to spend a ton of time on. I do think sometimes they're a little bit easier, and there are some things we have to use half angle, we can't use sum and difference. But this one could be done with either. So on your test, you'll probably have one question that says use the sum and difference identities to find this value. The other one will say use a half angle identity to find this value, because they can be done with either one. So for example 1, we've got sine of 7 pi over 12. Now, my formula for half angle identities is sine of theta divided by 2 equals plus or minus the square root of 1 minus cosine theta over 2. So what I need to know is I need this theta part. I need this to be something on my unit circle. 7 pi over 12 is not on my unit circle. So what I can do is I can just take this 7 pi over 12, multiply it by 2. You'll get 14 pi over 12, which is going to be 7 pi over 6. 7 pi over 6 is on the unit circle. Okay? So what I'm doing here is sine of 7 pi over 6 divided by 2 is going to equal plus or minus the square root of 1 minus cosine of 7 pi over 6 over 2. So if you're using a half angle identity, if you just double whatever your angle is, if that's on the unit circle, then you just put this number here, because half of 7 pi over 6 is 7 pi over 12, right? So we can use this formula here. Let's go ahead and figure out, too, this plus or minus here depends on what quadrant you're in. 7 pi over 12, what quadrant is that going to be in? Okay, second quadrant. Because this is 0, this is pi over 2, or we could think of that as 6 pi over 12, right? So 7 pi over 12 is just going to be a little bit past that. Second quadrant is sine positive or negative in the second quadrant. It is positive in the second quadrant. So we're going to use the positive for this. We will not use the negative. So you just want to see where what quadrant your original angle is in to decide plus or minus. So this gives us positive square root of 1 minus, 7 pi over 6. Not one we remember really well, probably. 7 pi over 6 is right here. And 7 pi over 6 would have the coordinates negative root 3 over 2, negative 1/2. Cosine is my x-coordinate, so this would be negative root 3 over 2 over 2. Okay? So, we've got a mess here because you've got square roots inside of square roots. And what I don't like about half-angle identities is that it never gets much better than this. So, what you're going to... I do not want a complex fraction, so please make sure that you do not leave a fraction inside of a fraction. The best way to get rid of that fraction is to multiply the top of this equation by 2 and the bottom of the equation by 2. Okay, we can do that. It's a legal move. So we would distribute 2 here, so we would get, we're still under the square root, 2, and then this minus and this negative here is going to make this a plus. And then what do we get whenever we multiply square root of 3 over 2 times 2? We get 2 square root of 3 over 2. What happens with our 2's? They cancel. So we just get square root of 3. The reason I picked to multiply that by 2 was because 2's in the denominator and it's going to cancel there. And this is going to be all over 4. And then they're probably not going to leave it like this with that 4 in the denominator, because can we take the square root of 4? We can. It's a 2. So they're probably going to leave it like this. 2 plus the square root of 3 all over 2. And there's nothing you can do about having that square root inside of the square root, so you have to leave it. Hello. Oh, I don't know if I have. That's math 3, isn't it? I don't think I've got anything, because I've not ever done math 3. I'd have to go back to algebra 2 stuff, and I don't even know if I have that stuff anymore. So I'm no help. Yeah. I've got lots of derivative problems, but they don't help you, do they? Yeah. I'm sorry. Then if you use sum or difference. But it will be the same answer. Like if we did this with double and half, we'd probably get square root of 2 minus square root of 6 over 4 or something like that. If we typed both of these into the calculator, we would get the same value. It would give us the same decimal. So our answers will look different whenever we use the half angle identity instead of sum and difference for these. Okay. All right, so let's do this one. This one has to be done using a half angle because there's nothing on the unit circle we can add or subtract to get 67.5. So if we're going to do this problem, if I doubled this, if I multiplied it by 2 here, so what will I get? I'll get over 5. 135. 135. So if I double this angle, I get 135. So I can do cosine of 135 divided by 2 because cosine of 135 divided by 2 is the same as cosine of 67.5. And I'm going to use my formula. So my formula is 1 plus cosine of, you're only using the 135, not the 135 over 2. The top part here is the number that goes here. And then it's all over 2. Okay? So 135, oh, that's on our unit circle. That is right here, correct? Yes. And this is going to be negative root 2 over 2 and root 2 over 2. So cosine is your x-coordinate. You're going to get negative, so you're going to get 1 minus square root of 2 over 2 all over 2. And we should probably think of whether we need a positive or a negative. 67.5 Is that in the first, second, third, or fourth quadrant? First quadrant, right? 135 is in our second quadrant, but the original angle they asked for is in the first quadrant. So we're going to have a positive here. We'll use that positive. So, right now, technically, you've got an answer, but it's probably not going to look like this if you've got like multiple choice. So, what could we do so that we don't have a fraction inside of a fraction here? Multiply by 2 on top and bottom of that fraction. So that will give us 2 minus, the 2's just cancel here whenever we do square root of 2 over 2 times 2, right? Those 2's just cancel. So we'll have 2 minus the square root of 2 all over 4. And then square root of 4 is 2. So this one will probably look like this. 2 minus square root of 2 all over 2. Okay, questions? Yes. Yep. It ends up being 2 a lot because the denominators on your unit circle are usually 2. So it normally is 2, but there could be some weird problem where it wouldn't be. Okay. All right. Last one. We're gonna find tangents. So I've got 112.5. If I double that, what will I get? 225, right? So we're going to find tangent of 225 degrees divided by 2. Which, let's see, 112, that is in which quadrant? Second quadrant, right? So 112.5 is in second quadrant. Tangent, is that positive or negative in the second quadrant? It is negative, because you would have a negative positive here, and tangent is sine over cosine, so that would make it negative there. So, around negative square root of 1, on my notes, 1 minus, right? Or is it 1 plus 1? 1 minus, yeah, I've written it wrong. 1 minus cosine 225 over 1 plus cosine of 225. And 225 is in that third quadrant there. So that is negative square root of 2 over 2 and negative square root of 2 over 2. So we're going to have negative 1 minus, actually it's going to be plus square root of 2 over 2, and then 1 minus square root of 2 over 2. Those signs change because when we plug in those negative square root of 2 over 2's, those will change. What should we do now? Multiply it by 2. So we will get negative square root of 2 plus the square root of 2 over 2 minus the square root of 2. And I think I'm just going to let it stop right here. Technically, you can rationalize that denominator so that you don't have a denominator that has a square root in it. But we have not done that, and I don't want to spend the time on something like that. So we're just going to leave our answer like this. Please do not leave me any complex fractions. So don't stop right here where you have a fraction inside of a fraction. But if you can get it down to this, that'll be okay. All right, questions? All right, we'll see your homework. Let's see if this is really the assignment that I want you to do. Yes, it is 14 through 32 all.